In this video, I will discuss sampling techniques and more specifically sampling terminologies, convenience sampling, which is a type of sampling, random sampling, systematic sampling, and stratified sampling, which are all types of sampling. A population is the set of all members about which a study intends to make inferences, and an inference is a statement about numerical characteristics of the population. For example, if you want to research study habits of students in American universities, the total number of students enrolled in these universities will be population. It is not feasible to collect data from all those students because they might be in millions. Collecting data from a large number of students will be very costly. So therefore, you decide to collect data from a sample, maybe 500 students or 1000 students, and that would be called a sample. So the sample is a smaller group selected from the population which is used to represent the population. A frame is a list of all members of the population. The potential sample members are called sampling units. Probability sampling is the technique whereby sampling units are chosen from the population according to a random mechanism. Judgmental sampling is another type of sampling in which sampling units are chosen according to the sampler's judgment. So that's not random. Whenever we do sampling, there is always a trade-off between cost and accuracy. So for example, in the same example, if you want to collect data from 1 million students, that will be very costly. However, collecting data from a large number of students will give you results that are likely to be more accurate. And when you figure out that it's not possible, and you decide to collect data from 500 students because that fits your budget, that will be more cost effective, but it will also decrease accuracy. Therefore, there is always a trade-off between cost and accuracy. If you go for a larger sample, it may give you more accurate results given that all other factors remain constant, but it will be costly. However, if you reduce sample size, that would be more cost efficient, but accuracy may decrease. Convenience sampling is the type of sampling which is non-probability sampling. Respondents are chosen based on ease of access, such as acquaintance or social media presence. The next one is simple random sampling. A simple random sampling is a type of sampling whereby every unit has the same chance of being chosen. Random sampling has certain advantages and disadvantages. The advantage is that it is random, therefore no bias. And there is also a disadvantage. It can lead to underrepresentation or overrepresentation of certain segments of the population. So for example, there is one book which has 1000 pages, and because of time constraints, you decide to read only 100 pages out of 1000 pages, and you decide to draw a random sample of 100 pages. Now, if you draw a random sample of 100 pages from a book which has 1000 pages, there is a possibility that the random sample can come from the first 150 pages, the last 150 pages, or somewhere in the middle of the book. And if that happens, that sample would not represent the whole book because it might be coming either from the front end, the tail end, or maybe somewhere in the middle of the book. Systematic sampling is the one whereby units are chosen from a larger population based on a regular interval following a specific pattern or system. Considering the same example whereby there's a book of 1000 pages and you want to read only 100 pages because of time constraints, and we know random sampling has certain limitations. In systematic sampling, you can read 100 pages in such a way that you read every 10th page. You read first page and then 10th page and then 20th and then 30th. So in this case, you will make sure that you will go through the entire book, and that is called as systematic sampling. The last one is called as stratified sampling. In stratified sampling, we divide our population into different layers, and those layers are also called as strata. Consider there is a company that's making vaccines, such as vaccine for COVID. They want to test vaccine on people from different ages because we know COVID is all about immunity, and that vaccine will also increase immunity. Immunity levels differ. Younger people have more immunity and older people have relatively less immunity. So the company may decide that they are going to divide the entire population into three groups. First group comprises people up to age 30. We may call them young population. The second group, or we can say second stratum, comprises people from age 31 to 60, and the last group will comprise people from age 61 to 100 or above. So the company develops three groups, and in the next step they will take sample from all these three groups. That's called as stratified sampling. The key to using stratified sampling is selecting the appropriate strata. Once you have developed this strata, the number of people in all these groups will be different. So for example, population of young people will be different from population of middle-aged people, and the population of young people and middle-aged people will be different from the population of old people. Therefore, for fair sampling, we use proportional sampling to make sure that all these groups are fairly and adequately represented. This is called as proportional sampling, which is a part of stratified sampling. This is our data that I will be using for random sampling. This is data for 50 US states, and our question is to draw a random sample of 20 states. So here we have three columns. One is states and random numbers, and then we will draw a random sample. So the first one is generating random numbers, and for that purpose I will use this formula, and then I will copy this to all other cells. Now one of the problem is that these random numbers keep changing. For example, if I enter here 3 and I hit enter, these numbers change. If I enter here any other number, a random number, again they will change. We don't want this situation. So I would like to freeze them, and for that purpose I will copy them and paste them at the same place, but paste only values. This one, not this one, but values, only values. Now these numbers are locked, they won't change. In the next step we will draw a random sample using these random numbers, and I'll be using this formula which comprises two parts. One is index, states, and then a ranking of random numbers. So my formula will be index these states. I will select this whole column and lock it by pressing F4 key, and then rank this one with respect to this whole column. I will select this whole column, and again I will lock it by pressing F4 key, and as you can see dollar signs appear here throughout. Parenthesis close. We need a random sample of 20 states, so therefore I will drag it to get 20 samples. To draw a random sample, Microsoft Excel performs two key steps: indexing and ranking. During the ranking process, Microsoft Excel arranges these random numbers in a descending order, which means that larger numbers will be at the top and smaller numbers will be at the bottom. In the next step, which is indexing, Microsoft Excel will correspond those numbers to those states, which mean that largest number in these random numbers will correspond to states at the top. So for example, whatever is the largest number here in this list should correspond to Alabama, and the smallest number in these random number will correspond to a state at the bottom. Then in the next step, because our required sample is 20, Microsoft Excel will check these 20 random numbers and identifies the corresponding state for each number. Essentially, this means that larger numbers in this list will correspond to states at the top and smaller numbers will correspond to states at the bottom. And as you can see here, this number is relatively large, this one, 0.9688. So it corresponds to Arkansas, which is somewhere at the top. Similarly, 0.905 is also a large number, so that corresponds to Connecticut, which is here at the top. On the other hand, very small numbers such as 0.04, which is a relatively small number, it would correspond to a state that's at the bottom in this list. So that corresponds to Washington. So it must be somewhere here at the bottom. This also means that if we, instead of just 20 samples, if we draw a bigger sample, then the highest number in our random numbers will correspond to Alabama, and the smallest number in this random list will correspond to Wyoming. The next one is systematic sampling. In systematic sampling, we choose a sample at regular intervals. For example, I may choose every fifth state. So for example, if I start with Alabama, the next one could be California, and then next Georgia, Iowa, and Maryland. And in this way, population is 50 states. So we can manually enter here 50, or I can use this formula, counting them the whole column, and that gives us 50, and our required sample is 10. So this is our question, which says draw a sample of 10 states using systematic sampling. And then the next step is finding out k value. K is the ratio of population and sample, so that will be 50 divided by 10, that's 5. Now there is another possibility. Suppose if we have to select 15 states instead of 10, and in that case, let me write here 50 and 15, and then k, value of k will be 50 divided by 15, that will be 3.33. We will round it off. So for that purpose, I will add here one step, that's round, and then to 0 decimal place, and that becomes 3. This is only for demonstration purpose. Over here 50 is divisible by 10, so we get 5. We don't need to round it off, but in some situations we may need to round it off. Here we will enter a number from 1 to 5. So 5 is our k value, so we will select a random number from 1 to 5, and for that purpose I'll be using this formula, rand between 1 and this 5, and that becomes 3. Now because it's a random number, every time I make a change here, this number will also keep changing. So in the next step, we will be adding this 5 to this one. So 3 plus 5, 8, 8 plus 5, 13, and we'll keep going. Now because this number, it will keep changing, so I'm gonna lock it. So I'm just manually typing here 3, which is a random number between 1 and 5, and then over here we'll be adding this 5 to 3, 3 plus this number, and make sure it's locked, and becomes 8. 3 plus 5, 8, 8 plus 5, 13, 13 plus 5, 18. So if I copy this formula to other cells, that becomes this one. In the next step, we will draw a sample that corresponds to this number. So for example, this is 3, and third sample in our list is Arizona. So here we'll have Arizona, and then 8. Number 8 is Delaware. So here we'll have Delaware, and then 13. 13 is Illinois. So Illinois here. So I'll be using this formula that's given here, index, name of states with respect to these numbers. So this is the formula that I'll be using. The name of states, and lock them by pressing F4, and with respect to these numbers, and again lock them by pressing F4, parenthesis close, and this gives us the same state, number 3, which is Arizona. We know that's Arizona, and then Delaware, Illinois, Louisiana, Minnesota. The beauty of this sampling technique is that it goes through the whole list. Compare it to random sampling. If you're using random sampling, there's a possibility that a random sample can bring you somewhere from these 17. But we don't want that. We want a sample that's representative of all the states. And in systematic sampling, we go through all the states and pick up sample at a regular interval. For example, we have here Arizona, and then Delaware, and then Illinois, and then we keep going until we reach the state number 48, which is West Virginia. So here is West Virginia, and we cannot go further because only 2 states are left. Now there is another way to draw a sample. Instead of indexing function, we can also use VLOOKUP function. This is VLOOKUP function. So we say that in VLOOKUP, look for this number in this array. So I'm gonna select this array, these 2 columns, and lock them by pressing F4, and then we say bring me results from the second column. So this is the second column, which is about states, because this is column number 2. Column number 1 is number, and column number 2 is states. So I say bring me results from second column, and then the last thing is that VLOOKUP requires that do you want approximate matches or correct matches. We do not want approximate matches, so therefore I will mention here false, and if I hit enter, that gives us Arizona. And if I copy this to other one, it gives us exactly the same sample as we had drawn by using indexing formula. So we can use two approaches. One is indexing and the other one is VLOOKUP, and they will give exactly the same results. Our next technique is stratified sampling. So for stratified sampling, we have this data. There is number one column that's about patients ID, and then this is about their ages, and then here we have a rule. So first the question is that draw a sample of 25, and rule is that we want 3 strata. So for example, imagine in a hospital or a pharmaceutical company is conducting experiments. They want to take a sample from different ages. So for example, if it is COVID vaccine and the company that is conducting experiment want to take a sample from different ages. They want to get some people who are less than 30, age 1 to 30, and then another group from 31 to 60, and the last group is for those people who are from 61 to 100, because they want to determine what is the impact. For example, people up to age 30 might have more immunity and they may not need vaccine. But on the other hand, people from 31 to 60, their immunity might be less than people in this group, and people over here, they have least level of immunity. So a company needs to take sample from different ages. So they will have 3 groups, what we call as strata. If someone is up to age 30, that will be stratum 1. From 31 to 60, that will be stratum 2, and 61 to 100 will be stratum 3. So for that purpose, I'll be using this formula. If age is less than or equal to this number and lock it by pressing F4, then that will be stratum 1. If age is less than or equal to 60, click this and lock it by pressing F4, that will be stratum 2. And in all other cases, 3. So this is the formula that I'll be using here. So for example, it says that for age 26, which is our first case, it should belong to stratum 1. And that makes sense because stratum 1 is from 1 to 30, because 26 is less than 30, so that will be stratum 1. And now I'm gonna copy this to other cells. So here we have, so for example, that is stratum 1, and as you can see that all ages in this group are less than 30. And then here we have stratum number 2, and you can see that in this stratum, which is stratum number 2, all ages are either equal to 60 or less than 60. So that's our rule here. And then we have stratum number 3, which has all people whose ages are 61 or greater. So you can see here that all these ages are either 61 or greater. So that will become stratum 3. In the next step, we will count that how many members are in each stratum. And for that purpose, I'll be using this formula, 1 in the top cell, and then this formula. In the top cell, I will enter 1, hit enter, and then if we say if this one is equal to this one, then add 1 to this one, or otherwise 1. So basically this formula means if C3 is equal to C2, so this is C3, this blue one is equal to C2, which means there is no change, then D2, this is D2 plus 1. And if this one is similar to this one, then increase it. So for example, if this is 1, when you add 1, it will become 2, 3, 4, 5, 6, 7, 8, 9. However, if this is not the case, which means C3 is not equal to C2, which means if this value is not the same as the previous one. So for example, over here, this is 2 and 1. If this is not equal to this one, then start counting from 1. So let me drag it. So as you can see here, it's doing counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means every time it says that this value is similar to previous one, it adds 1 here, and that becomes 3. And then it finds that this one is equal to this one, again it adds 1 here. This one is equal to this one, then it adds 1 here. So in this way, this pattern keeps going unless we reach 2, because over here 2 is not the same as 1. Now in this case, according to our formula, when this value is not same as the preceding one, then it will enter here 1. So let's see what happens. As you can see that over here stratum 2 is starting, and Microsoft Excel formula says that 2 is not the same as 1. So therefore it puts here 1. And then in the next one it says this one and this one, they are the same. So it just adds 1 here. And then again it finds out that this one and this one, they are the same. So it will add 1 here. So this is how this counting works. Now I'm gonna copy this to all other one. And as you can see here, so this is our stratum number 2. So all these values are 2 and it starts from 1, 2, 3, 4, 5. It goes up to 11. And then as soon as it detects that there is a new stratum 3, then it restarts counting from 1. For proportions calculation, I will see how many units are in stratum 1. So this is stratum 1 and I will count. So in stratum 1 we have 10. So I can either manually enter here 10 or I can use this formula, count these. And then how many members are there in stratum 2? Again, I'll be using this formula. And how many units are there in stratum 3? This is our stratum 3 and we know there are 15 members. So I can use this formula, count. So this shows in stratum 1 there are 10 members, in stratum 2 11 and 15 in 3, and total becomes 36, which is our total number of units in this frame. The next one is proportional sampling, and for proportional sampling we will see how many units we need to get from this stratum, second stratum and third stratum. So I'll be using this formula, which is sample in a particular stratum divided by total and multiplied by required sample. Required sample is 25 and total is 36 units in this frame, and sample in a particular stratum, for example over here we have 10. For proportions calculation I'll be using this formula, so that will be samples in a particular stratum. So here we have 10 divided by total, and we know total is 36. So either I can manually enter here 36 or I can use this formula that will count all of them multiplied by required sample size, and required sample is 25. So multiplied by 25. When I hit enter, that gives us 6.94. Now we cannot have 6.9 samples. We cannot have 6.9 patients. So we need to round it off. And for that purpose, I will make a small addition in our formula that will be round to 0 decimal places, and that gives us 7. Now I will use the same logic to calculate sample size for other stratum. Now this one shows that from the first stratum, which comprises 10 members, we will draw a sample of 7. Now I will use the same logic to determine the number of samples from other stratum. So for example, this one will be equal to 11 divided by total, and for total again I will count this whole column and then multiplied by, we need a sample of 25. So that gives 7.6, and again I will round it off to 0 decimal places, comma 0. And it shows that we need to draw 8 samples from second stratum. Similarly for third stratum it will be 15 divided by total, which is 36. And I will also round it to 0 decimal places, and that gives us 10. If we add them, 7 plus 8 is 15, 15 plus 10 will be 25, and we need a sample of 25. We need to draw a sample of 7 members from the first stratum, and first stratum comprises 10 members. From the second stratum, which comprises 11 members, we need to draw a sample of 8, and from the third stratum, which comprises 15 members, we need to draw a sample of 10, and the total of 7 plus 8 plus 10 will be 25. Now in the last step, we'll be using this one, that's included or not included, and I'll be using this formula. If this number is less than or equal to this one, and I will lock it by pressing F4, then it is included, and therefore I want here yes, or otherwise no. Now I will need to do it separately for all stratum. Let me drag it to all members of first stratum, and it shows me, so it shows me that these 7 members are included and these 3 members are not included. So as you can see, we needed 7 members from stratum 1. So these are 7 members that are needed. These 3 members are not included in the sample. We repeat the same step with second stratum, which will be if this one is less than or equal to this number 8, lock it by pressing F4, then yes, or otherwise no. I will copy this to other members of this stratum, and it says that these members are included, and you know that for the second stratum we need 8 members. So these are 8 members that are included, and these 3 are not included in the sample. And in the last one, this is stratum number 3. So I will use this formula. If this one is less than or equal to 10, that's a required sample from stratum 3, and lock it by pressing F4, then yes. If it is not less than or greater than that, then it should be no. So when I hit enter, that gives yes, and if I copy this to other cells, it gives us this one. And as you can see here we have these 10 units which are included, and actually we need 10. According to our scheme, from stratum number 3 we need 10 members. So these are 10 members that are included, and these are members not included in the sample. We end up having a sample of 25. This is 7 from stratum 1, 8 from stratum 2, and 10 from stratum 3. I want to show conditional formatting, which will automatically turn yes into green and no into red color cells. Select the whole column, and I will click on conditional formatting, and in conditional formatting I click on highlight cell rules, and then I will click on text that contains. So I mention here that if our cells contain this text yes, I want it to appear as green. I click on custom color. So I want this type of color. When a cell contains yes, I want this type of color. So click on OK and click on yes. And as you can see that all the cells which contain yes, they have turned green. In the next step, we want to turn these no into red or pink color cells, and again I will select this whole column and I will click on conditional formatting, highlight cell rules, and then text that contains no. So all those cells that contain no, I want them to turn into red or pink color, and if I click OK, all those cells that contain no, they are automatically turned pink colored. So that makes it easier for us to distinguish which one are included and which one are not included. The last step is to find out if a particular patient is included or not included. If you want to find out if patient 4809 is included, 10026 included or not, and for that purpose we will use here VLOOKUP function. VLOOKUP for this one, and currently it's empty, but later on I will be adding here any value. Look up this one in this table. So in this whole table, and lock it by pressing F4, and then bring me results from this column, and the number of this column is 5. 1 2 3 4, and this is 5. So I mention here 5, that bring me results from column number 5. And the last thing is that it asks, do you want approximate results? No, we want exact results, so therefore I will enter here false and hit enter. Now for example, let's say this is the number 4809. I add here 4809 and let's see what happened. 4809, if I hit enter, it says yes, this sample is included. And as you can see, 4809, it is yes, it is included. Let's go for this one. This is 10026, and let's see what happens. 10026, and it says no, this unit is not included.